Yeah, you have 100 shillings in the pocket, and that is the only one that you're supposed to use for your needs. And you have felt your favorite food cooking, which you think, so your head says you need to buy. Your brain reasons that out and it says you need to buy. Well, you buy, that will be a good action because you have responded to your environment, meaning that you are an agent, you are fully an agent. But you lack rationale as an agent. You lack rationale because was that action responded to the environment? Yes. But was that action preferable? No. That action was not preferable because you only had 100 shillings in your pockets. So what are you going to keep for next time? So that action is not preferable. It is a good action because it has responded to its environment, but it's not preferable. Also, it does not have the best performance measure. In other words, it's not the best odds for you that bet, which is I always discourage you from betting and work. Yeah? For you that bet, you talk about odds in gambling. So what are the odds after performing that action? What are the odds? That is what we call performance measure. Performance measure is measured in terms of percentage. Like that action was 90% okay, 80% okay. Yeah. What are the odds? What are the odds that that action best suits its environment and also best suits the agent? All agents must be analyzed after all its actions to determine its what? To determine its performance measure. When a robot is developed, always there is an analysis that is done every time when a robot is deployed, right? It is returned to its base and all knowledge from its knowledge base and every action it performed, everything that it performed from time A to time Z at the period that it was deployed, all that information is downloaded by an AI scientist, and then its performance measure is measured. Its performance measure is measured to look how did it perform in different given occasions. So it will be rated in terms of percentage. It will be rated in terms of percentage. Now, there is sometimes also an app, when you download an app, they allow you to rate. They allow you to rate. Now, the reason why many apps, they always require you to rate their products or to rate their app is because they use that to measure what? Performance measure. All right, to measure the performance measure. The information that you give during your review or your rating enables them to maximize on the performance, to help the agent, the app being the agent, which has linguistic knowledge or other kinds of knowledge, to be able to perform better. So that is how analysis is done for an agent to determine that its performance is high. The performance should be high. And then, so when we have an agent that has a high, it performs actions that have a high performance measure, meaning that the odds of it giving good results, accurate, best possible results are high. Those odds are high. And also that agent performs actions that do not affect its environment, negatively. We can say that that agent is rational. All right. So a rational agent is an agent that performs actions that have the best performance measure, actions that are most preferable, and number three, actions that have the least negative impact to its environment. Consider a car. Consider a self-driving car. A self-driving car will have infrared sensors or infrared rangefinders and cameras for seeing images around it and such things. Now, if a car is driving and they see a pedestrian and it is engaged on a highway, now already in its own code, it knows that when it has seen through the infrared rangefinders and also the cameras, it has determined that there is no other car around it and it's on a highway, and it has read it has radar, probably one of the signboards, the road signs that minimum speed limit is 120 because it's a highway. You can't stop. You have just to move. What should that robot do if a pedestrian crosses? If a pedestrian crosses, or it's a highway, but normally there are wildlife that normally pass through that region. What should that robotic car do when it sees a barrier, and in this case it is an animal or probably a pedestrian that is lost, just decided to pass through? Of course, they are not supposed to pass there, but they are there for some reason. So what should the robot do on those occasions? In those occasions, it should slow down. It should slow down because it has infrared rangefinders. It should slow down, though its code, the code that it uses, the generated at that moment, tells it that it is time to move at 120 or more, but there is a barrier. Yeah. Now, for instance, if it's an elephant, let's say, even not even a pedestrian, and there are people in the car, do you go and crash to an elephant? You will kill everybody in the car. Yeah. So it needs to perform actions, what we say call circumstantially. Circumstantially. What that means is that it needs to treat every single circumstance as an independent circumstance. You should not treat all circumstances in the environment as one circumstance. You treat every circumstance as its own independent circumstance, its own independent situation. So you should view every circumstance as one, not a general circumstance. So driving is not a general circumstance. There are other factors during driving, right? There are things to do with observing road signs. There are things to do with looking at whether there are possible barriers before you. So you'll find that most cars, they are built with rangefinders where if there is a pedestrian that is crossing, that car will place the value of that pedestrian as high as the value of any other passenger in it. And so it will have to slow down or swerve. It will have to slow down or swerve. So those are what we call rational agents. Rational agents perform actions that have the best performance measure. They are the most preferable. Of course, killing someone is not preferable. Swerving or slowing down is the most preferable. And that action it has the least negative impact in its environment. So whether it's a swerve or it's a slowing down, that car must decide what to do based on something that will not affect its environment, negative. For instance, if it swerves, it might roll over and therefore kill the ones that it was trying to save. It was trying to save a pedestrian and also save these ones that are inside. So if it swerves, it will roll over. So of course, what should it do? It should slow down. So that's how rational agents basically determine what is the best possible action. Now, if an agent can determine the best possible action, it has a set of actions, but it can arrive to one which is best considering some given factors, then you can say that agent is rational. Now, this app called Eliza, the one that I showed you in the beginning of our previous classes, that app is not rational because if you give it a question like, what is your name? What do you like doing? It will not give you direct answers. You may even find that it repeats itself in some answers because it is not rational. It's not able to give you the best. It's not able to give you the best. I can actually say that Google search engine is a rational agent. Why is that conclusion plausible? That conclusion is plausible because number one, it gives me results that are best preferred. The links, when I search, with Google, intelligently it is able to generate the most frequently searched, the most frequently visited links that have that keyword or that key phrase or those key texts. Links that have that is able to give me all that. So it is a rational agent. So an agent is said to be rational when it performs the best preferred action. That action has the best performance measure, meaning in terms of percentage, it is on an high, and it has the least negative impacts on its environment. Basically, a rational agent is one that does the right things. That is basically a summary of that. It is one that does the right things. And an agent is assessed by ratings, as we had said. For you to determine how rational an agent is, it is determined by ratings. And you have said, like for apps, you give it reviews, you rate an app, and therefore they are able to kind of they're able to improve that app, and then it is able to have more intelligence. Yeah. And that is why, Johnny, mambo tu ya data analytics, data science, putting data in agents. So what happens is that all the information that you give when you are rating an app or when you are reviewing an app, what happens is that all that information, they take it and they represent that you like code. So if you say that an app needs some more handles for close, a handle for pause. For instance, if you are giving a rating for a media player app, so you tell those guys as you rate, this app needs, I need to be able to, if I remove my earphones, it should be able to pause. It should be able to pause what I was playing. Yeah. So that will be integrated in the code. Yeah. And so it will have knowledge of when an earphone goes in and when an earphone goes out. So when an earphone goes in, it plays back. When an earphone goes out or a headset goes out, it pauses. So basically they use ratings or the knowledge that you give because they need data. And when you provide data through your rating, then they're able to improve the app. So that is basically the thing about rational agents. So yes, we have talked about that. So now let's look at the structure of an agent. Now, an agent is made up of two things. For it to be an agent, we had said actuators, sensors, effectors, and knowledge base, right? But we are going to summarize all that into two things. An agent is made up of two basic things. Number one, an agent is made up of its architecture, and an agent is made up of its program. Okay, so these are the two main parts of an agent. Now, if I ask you the main parts of an agent, if you tell me sensors, actuators, effectors, knowledge base, I'm going to agree. Those are parts, all right? But if I ask you what is the structure of an agent, you must give me this summary. An agent is made up of architecture and the agent program. The architecture is the machinery that an AI agent executes on, the machinery, the hardware. Okay. So for a robot, it may be the steel, the metal, the motor on its joints. It may be the hard disk within it. It may be the CPU that helps it to process. The machinery, the hardware capabilities of an agent is called the architecture. And then the agent program, also we also call it agent. The agent program is the software that enables it to perform its functions or to perform its actions. So the software upon which it runs is called the agent program. Now, I told you that in advanced levels, you're going to be developing AI systems using Python. Python is and there's another called Ruby that helps you to develop agent intelligence systems that run on mobile or mobile apps. Ruby. So the program that you develop is called the agent program, the program that makes the agent to do what it does. And the agent function is basically a map that helps an agent to find its way to the best possible action. It is a map, it is like a route, and it passes through channels called nodes. And we are going to look at that. Let me just draw for you so that now you can know what I'm talking about. Let me just draw for you so that you can know what a function is, an agent function. An agent function. Let me refresh this page.
You are currently the only person in this conference.
Okay, let me share this screen with you. We're going to have all right, we're going to have some shapes here. Going to distribute them in a random way. Right. So then I'm going to use lines to join. It will look like a mesh. It will look like a mesh. Now, what is this? What we have here in circles, is what we call nodes. Node. All right, let me. Now, in networking, you discussed nodes, right? Node. Let me increase that so that you're able to see better then. So, single of these is called a node. This is a node. Then is a route or a route, whatever you call it. Is a route. Now, what is the work of a node? A node is basically a representation. It's just a diagrammatic representation. A node is a diagrammatic representation of a possible action. These are actions, kinds of actions that an agent can perform. Okay. Now, the first node in this mesh system is called the problem node. The problem node. It is the problem the agent is trying to solve. And then this is the best possible action, the last one, when all the system, it has traversed through the different routes, right? So an agent function is this mesh system is what we call an agent function. All of this is what we call an agent function. An agent function is basically the mapping, how it is the algorithm that the agent uses to traverse through different possible actions to reach the best possible action when it's trying to solve a problem. So when it is from the least complex to the most complex, every time an agent will have to traverse through nodes. And those nodes are basically representations of possible actions. Now think of yourself using your brain. There is a way you function. There's a way you come to a solution. You normally say things like, okay, if I do this, what will happen? Alternatively, if I do this, what will happen? Okay, then I will do this. After that, I will do this. Then after that, because this will have this kind of effect, I will do this then. Then after that, I'm going to do this, and then I'm going to achieve that finally. So whatever you are planning, for you to arrive to a solution is basically a function. The function is basically the network of possible actions that you will perform on your way to the best possible action. Okay, so that is what you call agent function. Agent function. In fact, let me just write it there. Agent function. So if you are asked what is an agent function, an agent function is basically the algorithm that an agent uses to traverse through different possible actions to reach a final action that best solves the problem at hand. Best solves the problem at hand. So that is what an agent function is. That is what an agent function is. So the way in which you traverse through nodes, and nodes are basically best possible actions that you do or fail to do as you traverse through the function, the mesh, the network, to reach your best possible action. That is what you call a node, a function, an agent function. Now, the program, we say that the agent program, let me bring this screen back up. So the program acts on the function. The program acts on the function. There we go. The program acts on the function. What do we say? What do we mean that the program acts on the function? The program is there to enable the agent to traverse through the nodes. It cannot do that if it doesn't have a program. And that program will have what we call control structures. You remember control structures from programming. If else, nested if else, switch, for loop, while loops, do while loop. In other words, control structures are basically statements, code statements within a program that help the system to navigate, to go through different stages when certain conditions are met or not met. So of course, if a robotic agent like let's say an autonomous car is driving and it sees a pedestrian on the road and it's racing down the road, so it has to come up with the best possible action for it to be rational enough. So the best possible action is to not. So already the knee has been determined. Do not overrun on the walking pedestrian. So it has now to come up with the best possible solutions to perform that action. All right. So it has to swerve, it has to slow down, it has to hoot, those kinds of things. So an agent function is basically an agent program works on that. It enables the agent to traverse through its function so that it can always come up with a solution. And the function is normally made up of control structures. In programming, we talked about control structures: selection, sequence, and iteration. All right. So that is what an agent program is. So when I ask you the structure of an agent, these are the two things you're going to see. An agent is made up of the architecture and the program. The architecture is the machinery or the hardware system, and the program is the software, right? Yeah. And the function is the manner in which it reaches its best possible action during a problem. Ignore this. It's just something to illustrate a function and a program. That statement is not very important there. Okay. Then let's have what you call the piece representation and see all this. What is this rationality? So remember, we are still talking about rational agents that they perform actions that are best preferred. They have the best performance measure or the highest performance measure, and they have the least negative impact to the environment. So we are still continuing with that. So what is this we call piece representation? Piece representation, PEAS, is an acronym. Now it's just a model which defines rational agents. It's a model for defining rational agents. Now for rational, in a piece representation model, an agent is made up of four things. Its performance measure, all right, the percentage used to measure how best is that best action, yeah, and then its environment, its actuators, and its sensors. All right, so this is what you call the piece model of an agent. The piece model is just a model to determine agents and their rationality, or what we call rationale. Piece is basically a model that is used to determine or to study agents and their rationale. So the best way to measure the rationale of an agent is to measure its performance measure, and it is always in percentage, 0 to 100. So the performance measure in the piece model is always the objective for the success of an agent's behavior, not how it impacts the environment, not how its actuators work or how its sensors work, but the combination of all these actuators, sensors, knowledge base. Do they work together seamlessly to come up with solutions that have the best performance measure? So performance measure in the piece model is the highest concern. It is the objective for the success of an agent's behavior according to piece. Now, for instance, piece for self-driving cars. Let's look at piece for self-driving cars. How can we study a self-driving car using the piece model? Performance. The performance of an agent, this robotic agent, is measured in terms of its safety, time, how much time does it use to travel from point A to point B, legal drive? In other words, is it able to obey traffic lights? Is it able to read road signs? All right. The comfort of the car itself. And also, I should add, there's something I should add here. The cost, the economy, the cost. How much fuel does it use? All right. Does it accelerate? You know, there's a way when you're driving a car, there's a way you can be accelerating when you don't need to. Or you are accelerating on a road, you don't need to accelerate. You can accelerate, but you don't need to. Yeah, to save on fuel. Yeah, so economy, that is another performance criteria. All right. What are the environments? The environment within this car are the road itself, other vehicles, road signs, pedestrian, even the passenger in it. Okay, even the passenger in it is in its environment. So those are environments. Environments are basically the entities that the system interacts with internally or externally. Okay. All right. Then actuators, or let's go to sensors first. Sensors are cameras, GPS, the GPS system to identify the routes to take, the directions to take, where to drive, the roads to take, the speedometer, the odometer, the accelerometer, the acceleration system, the sonar system. Basically, these systems that help it to receive percepts from its environment. And then the actuators are the steering wheel, the accelerator system, the braking system, the signal, the horn, or the hooting system. Yeah. So basically that is the agent. So of course you may even be told using P's representation, discuss the following agents. Medical diagnosis system, right? So you would say performance measure is health of the patient, minimized cost of treatment, and cleanliness, maximum cleanliness when handling a patient. What is in its environment? The patient itself, the hospital staff, the room. What is its actuators? What is its sensors? What does it use to receive input from its environment? Keyboard, a mouse, yeah, because it is the staff or whoever is using it should type in the kind of what symptoms they feel, headache, rushing fever, a running stomach, things like that. So it needs a keyboard for entry of symptoms, and it needs a mouse click for entry, for accepting options, things like that. It can ask you, is this the only thing that you feel? It can also ask you, based on now what you have given it, do you also feel this? And it can ask you, so you can say yes or no. Do you think, it can ask you, it's like a wizard, it's like an interactive system. Yeah. And then it now tells you these are your symptoms, and these are the possible things. So the possible diseases. So the sensors are the keyboard, the mouse, even the camera. Why camera? To read your eyes. Probably your eyes are weak, or there are those diseases where they test your eyes to see if there is infection, or your eyes can tell whether you're sick of something, So cameras to look at your eyes, dirt detection sensor to determine dirt in your hands, things like that. And I don't know why that is necessary. Why should somebody be dirty be considered as a disease? Anyway. But we can also talk about a biometric scan that can feel your temperature. That will be another sensor. Yeah. A biometric scan that can feel your temperature. It's like a biometric thermometer. You just place your hand on it and it can feel your temperature, or it can feel your pulse. Right? And then actuators, it will perform tests, it will perform treatments and such things. You can be told, explain the piece model in terms of a vacuum cleaner agent. A vacuum cleaner is a simple agent. and we're going to talk about categories of agents. A vacuum cleaner is a simple agent. So what is the performance measure? The performance is based on things like cleanliness, efficiency, battery life, security. The environment of a vacuum cleaner, it's the room itself, the table, the wood floor, the carpet, the various obstacles, even people are obstacles. When people are passing through that room, that cleaner should be able to stop and let them to pass, things like that. The environment could also include just things on the floor, like uh, flower vases that have been placed on the floor. Yeah, flower vases. Yeah. And then what are the sensors? Cliff sensor. What is a cliff sensor? A cliff sensor is just a sensor that determines that you have come to the edge of a floor. For instance, if you are cleaning on top of a floor, na kuna beyond it, there's no wall. So that means if it goes on, it will fall over. So it needs to have a camera to determine when there is a cliff, when it's just about to fall over. It needs to have a bump sensor. What is a bump sensor? A bump sensor is one that determines that the flow is not regular. So the flow should be regular. A bump sensor will determine that should, whatever is not regular on the floor is that. So it can be stone, it can be paper, you know. Yeah, and infrared wall sensor, so that when it reaches to a wall, it can revert back. It can come back. It reaches that wall, it goes back, or it reaches a wall and it moves around that wall cleaning. You know, yeah. So those are sensors, and then it uses wheels as actuators, brushes for cleaning, vacuum extractor. So I hope these things are very very clear to you. The piece model of an agent. It is used to, the piece model is used to understand the parts of an agent and its performance measure. So the performance measure, the environment, the actuators, and the sensors. Okay, that is a piece model. So when I ask you, explain this blah 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 agent using the piece model, you must be able to explain to me what is the performance of that agent. Yeah. Now let me give you a kind of agent. Give me, explain. Let me type here. Explain this model in light of let's have a what? Light of the Google search engine. Explain the piece model in Google search engine. Explain that in just a minute. All right, somebody to explain the peace model. Somebody to explain the peace model, or just to describe the Google search engine in light of the peace model. Describe the Google search engine in light of the peace model. Describe the Google search engine in light of the peace model. Basically, what you are saying is performance. What is the performance measure? In other words, what should it do? Yeah. And then what is its environment? What is the actuators, and what are the sensors? Somebody? So Juma Vivian says performance. What is the output? The necessary results that an agent gives after processing comes under its performance. Okay. So I need you to give me specifics, Juma. Give me specifics, like what is the performance of that search engine? What is the performance of that search engine? For instance, for a medical diagnosis system, the performance measure is determined on the health of the patient, minimized cost, and cleanliness. For a vacuum cleaner, the performance measure is based on the efficiency, the battery life, and the security. All right. So what will be, in other words, what should what should it do? What should it do best? What should it do best? What should be considered when doing those things? So it's performance, it's environment, it's actuators. Like, let's begin with performance. What is the performance for that system, for a Google search engine? How do we determine that it has given you performance, the best performance? It has performed the best way. Okay, Mwangi Jefferson, sensors. Sensors, audio keyboard. Yes, the audio keyboard is also the typing keyboard, the normal traditional keyboard. So the keyboard is a sensor. All right, so that's the performance of a self-driven car. So what is the performance of the Google search engine? Actuator is data. That is true, Mwangi. The internal data of the search engine it's the actuator. It helps it to produce output. Without that data, produce output. So just put your answers there. I'm going to review all of them together. Keep contributing. I'll answer all of them at once. I've not seen contribution by Kimorata Dennis, Kipkirui Edmond, Menganyi Chacha, Hillary, Jefferson. I've not seen your response. John Deritu, Saruni, Margaret, Jefferson. I've seen your response. Stacy, you to respond. So, what is the piece for a car? What is the performance? What is the environment made of? What are the actuators and what are the sensors? I need to see your response so that I can answer all of it together. All right, so Collins says displaying of the output is the actuator, environment is a person, Mwangi Jefferson, Collins Cavella, data displayed on the screen, actuator. Okay, now let me share this screen. Now you can see whether you're right. So look at this screen here. The piece for the Google search engine. Press start so that it can be there. The Google search engine, this is how the piece can be represented. In other words, what are the components of the piece model for a Google search engine? Those are the ones I've just typed them so that we can see them instead of saying it, just saying it. So performance, the performance is basically what it does and how best it does it. So the performance measure of that search engine is measured in terms of how fast does it bring results. So the speed of output, right? How fast when there is optimal network or there is optimal internet connectivity, how fast is it able to generate results? Okay. And then what is its accuracy of that search? That what I call word-to-word search accuracy. All right. And is it able to bring the most frequently searched that can help you to filter down your search? Like for instance, type your search, type your search for search engine. Does Google bring you most frequently searched or relevant searches? So instead of you keeping to type, you just press enter. You accept the they are called suggestions. You accept the search suggestion, right? So is it able to do that? In other words, how do you measure that the Google search engine performs optimally? You measure it using a performance measure. That performance measures in terms of how Google's first engine, how fast is it in producing output or generating output or results? How accurate are the results? Between Bing and Google, we all know that Google is the one that has the highest word-to-word search accuracy. Yeah, Bing itakuletea vitu zingine, utapata links. The first 10 links are okay, but the other ones they are not even related. And then the most frequently searched, yeah, the Google is able to bring you the most frequently searched things, right? That is what we call the performance for Google search engine. And then the environment is basically the internal functions, the internal and external things that the mini interacts with. So what does a system, Google search engine as a system, interact with? It interacts with URLs. It also interacts with the human user. What are the sensors? I normally, okay, they follow each other in like PEAS, but I normally, before I write the actuators, I go to the sensors, because it is from sensor that I'm able now to determine the actuator in some way. That's how my brain functions. So the sensor is basically things that the Google search engine uses to receive input. So it receives input through keyboard strokes, so it needs a keyboard, mouse clicks, so it needs a mouse, and it needs your voice, so it needs a speech recognizer. Yeah. Then for it now to be able to generate results from its knowledge base, it must use actuators. So it uses a query algorithm. In other words, a filter to filter down the search. You studied database, I believe, so you know what a query is. A query is a search criteria. So it needs to use a filter to run through the best possible results so that it can now display. And then it requires your screen to display. Right, so you see how that works. So that is how that works. Okay. So there we are. So any question about anything that we have learned so far? Any question? I hope that the unit is self-explanatory. It's flowing. I hope that the unit is flowing and you can understand. Yeah. So you can basically pick anything, even those chatbots that you interact with, like in a Jarvis, and such kind of chatbots that you interact with your phone or anything, any intelligent system that you know. You pick that intelligent system, then you try and explain it using the piece model. Okay, using the piece model, and that is exactly normally what you find. Okay. Now, just as an addition, effectors and actuators, there's a little difference, but when explaining the piece model, you treat effectors the same as actuators. Actuators are the ones that set a system into motion. And then an effector is the one that directly influences its environment through that particular motion. So for instance, ukiangalia hapa kwa tulisema kwa robot, for a robotic agent, let's say a self-driving car, an actuator will be the accelerating system, okay? But the wheels are the effectors. They are the ones that literally affect the environment. They are the ones that literally work on the environment, the wheels, okay? The wheels. But explain using the piece model, explain actuators na effectors as the same. Accelerator system na wheels zitakuwa actuator. Okay, so ndio maana umepata kwa search engine hapa, query algorithm is not an effect, it's not an effector, it's an actuator. But screen is not an actuator, screen is actually an effector. Okay, the one that directly, so effectors and actuators, they just work together, but effectors are the part of that system that directly influences the environment. So the screen is the one that directly shows the output, but the query algorithm is now the internal function that runs the output. Okay, yeah, that runs the output. So it's this is the actuator, this is the effector, but tukitumia piece model tuna explain zote kama actuators. Okay, because basically actuators and effectors, they do the same thing, and that thing is to respond, to perform an action corresponding to the decision made internally. Okay, yeah. So any question? Any question? Nani hajaongea? Elvis. Elvis. Margaret. Stacy. Edmond. You guys have been quiet today. I need you to talk. Edmond and Chacha. John. John alienda wapi? And Saruni. So I'm going to give you then an assignment for 5 marks. And that assignment is going to be in your, the assignment is going to be, just a minute. The assignment is going to be in your, you're going to find it in your portal at your end. So utaipata hapo kwa mahali tumekuwa na session ya leo. Utapata nimeweka assignment hapo kwa session ya leo. Utapata assignment hapo. So that will be assignment 1. It will be 5 marks. And then I'm going to tell you how you're going to send it. I prefer that we don't use Google, the mail, but I'm going to find a way in which you're going to send there. send the assignment. So I'm going to put that assignment there. It's going to be our assignment 1, and it is due 1 week, just 5 marks, so you can do it as fast as possible. So it is due 1 week, and then next week will be 1st of June. We'll hit our 5th week. That will be our 5th week. 5th week, yeah. So 1st of June, you're going to do your Cat 1, right? Your Cat 1 for artificial intelligence. So 1st of June, you're going to do your Cat 1. Now, the way in which you're going to do that Cat, I'm going to communicate further in your WhatsApp group. And also the assignment, the way in which you're going to submit that assignment, I'm going to communicate further in your WhatsApp group also, right? So basically, yes, Juma, we cannot follow the timetable fully. The reason being, there's what we call teacher autonomy or teacher independence. I look at what you have covered and I test what you've covered. So I know the timetable says something, but it is basically for me to say when you're doing it depending on what you've covered. Otherwise, if I teach more and I test, it will mean that I test more, meaning that your cut will be more than 15 marks. Okay. So it is important that I look at what we've covered, and then I tell you when we do that cut. Okay. So that is how it works for me, and also for you, because basically I am the leeway. I am the bridge to the school. So it's me who informs the school how far we've come. So it is important that when I feel that it is necessary that we do a cut, then we do a cut, because I'm the one taking you through. The school does not know where you are. The management does not know. Right? I'm the one who knows where we've covered content, and so we're going to do the cut on the 5th week. That feels better, and it also allows you to focus on the things that we've learned. Otherwise, if we follow the timetable, we might push so much, right? So it is important that we follow the content that we have covered, right? So assignment 1, you're going to you're going to do your assignment 1. And when you do your assignment 1, we are going to keep in touch in WhatsApp, and I'm going to inform you how you're going to submit assignment 1. But remember, due diligence is important. So next week, by next week on 25th, on 1st of June, I will require that all cards be submitted in the manner in which I'm going to say they be submitted. So by first, kila mtu anafaa kuwa amesubmit your assignment 1. It's just a theory assignment to test your understanding of what you've learned, and then tufanye cut 1 on 1st. All right, tufanye cut 1 on 1st. That will enable us to cover our content better. Then tuendelee hivyo 10th week tufanye cut 2, something like that, or 14th week, depending on where we're going to be. So that's how I need us to run the course. At some point where I feel like we've covered much, I will test you. All right. When I feel like we've covered a little, I'll push a little bit forward so that we can cover more, and then I test you. So basically the timetable is just to guide us. Okay, just to guide. The cut timetable is to guide us, to expect, to keep you ready as a student, when to expect that, during what duration to expect your cut or your assignment. It's just for a guide. Yeah, it's to guide you, yeah, to know that the assignment or the cut will be done or delivered at this particular period of time. But it is what really sets the date for the cut is the content of the work done. So after to make our content, we still follow the timetable, but we adjust based on where we are on the content. Okay. Yeah, so that's how it needs to work. Needs to work that way. So that is it for today. If there are no other questions, then I will wish to stop at that and then we continue. As you have observed, you have not even gotten to categories of intelligent agents, which was our meaning, but we have discussed what rational agents are and what is the peace model of agents. So I'm going to put the assignment in your portal. You're going to find it there in just a few minutes. So when I log out, when I close the session, I'm going to set that assignment for you and put it there. So you're going to find it in the next 15 minutes. You're going to find it there. So that is it for today. Have a good day and keep yourselves safe.